This is Kosmographia, the Randall Carlson podcast. Welcome back, ladies and gentlemen. Kosmographia. This is, what did you say, Brad? Episode 55?
That's right.
That's right. Yeah, 55. Episode 55 of the Randall Carlson podcast. So, Randall.
Sir.
Before we all start talking about other random stuff, I just want to know, what are we going to talk about today in the main part of the show?
You mean I have to commit to a certain course? Okay. All right. Well, we're going to continue to discuss the mega flood features around the North American continent, because I want people who live in North America to understand and appreciate how these gigantic flood features are everywhere about us, in everyone's backyard, so that people who are living around, adjacent to, on top of these magnificent features can begin to see for themselves what's going on in terms of the geomorphology. And also then, because one of our goals here is the effort to try to reconstruct these events. And so what we're doing is we're looking at the geomorphic evidence that's preserved in the landscape to try to reconstruct the events. It's very much like forensic geology. We're coming in and we're looking at the clues and the features that have been left over from an event that happened that we didn't witness. And so we have to look at the clues. We have to look at the evidence that's been left behind to attempt to reconstruct the event. And so we'll pick up where we left off. We were talking about the FingerLks.
That's right.
Yeah, we were talking about the FingerLks, and I thought it was interesting that, let's see, we recorded our podcast on the 30th of November, right?
Yep.
And then on the 2nd of December, we had a fireball over New York.
That's
and
right.
Let's see, I think I have...
Pretty big one.
Yeah, let's see here. So
Yeah,
for those of you who are listening in, of course, this is all old news by the time this gets posted, but nonetheless, the sequence, the chronology here is rather interesting. So
that's right. And on the 30th, last week when we recorded the previous show, we also showed some video of the fireball that came down over Japan on the 29th.
Yeah.
Right.
Yeah. And apparently, I was just looking into it some more, and apparently that one there was a previous one in Japan of this year also that came down in July, or at the end of July, that they eventually found pieces of.
Mm-hmm.
But the one that was on the 29th, it actually made noise. People heard it. So it was...
The one they found pieces of, was it a chondrite?
I couldn't find... They didn't say what it was in the articles I was reading, so I needed to keep looking for that. But yeah, I think it was... I saw pictures. It didn't look metallic. So,
okay. So I'm going to do a share screen here. All right, here we go. So here it shows the fireball path. So I thought this was rather auspicious. We've been discussing the Drumlin fields extensively over a couple of episodes now in the FingerLks. And that was the primary topic of our November 30th recording. 2 days later, we get this fireball directly over the Drumlin field. And as it says there, a momentous boom rocked parts of upper New York State on December 2nd after an exceptionally large meteor infiltrated the Earth's atmosphere. The explosive flash produced a brilliant shadow across the city of Toronto, and the far-reaching roar from the explosion created seismic-like shaking across portions of north central New York. Now, I haven't seen any video clips of that yet. Have any of you guys?
Yeah, I sent you a link to the video clips.
Oh, yes, you did. I got so engrossed into it had a video clip of Chelyabinsk in there. Did you watch it long enough till they had the video clip of Chelyabinsk?
I don't think I did. I think basically just watch the Toronto stuff.
Go to 8 minutes and 25 seconds of the video you sent me.
Yeah, they've got a pretty good Chelyabinsk video in there.
Yeah,
but
turn the volume way up.
Yeah, the initial, the earlier ones showing the Toronto one, it was a daytime meteor, right? It showed up in the sky during the day. It was bright enough to do that.
And when you see the footage of the flash over Toronto, I mean, this thing was over New York, but it lit up Toronto, which must have been 100 miles away.
Mm-hmm. Well, they must have seen it in Buffalo or Rochester.
Yeah, but I haven't seen videos from Buffalo or Rochester, just Toronto.
Yeah, right over Syracuse, basically.
Yeah, right over. Well, I'm sure that there's some out there. I haven't had a chance to look for them yet. But
and this will be something that we'll get into. We'll have a separate, shorter episode where we can do, the latest current events. It's going to take a little time and some outside funding, perhaps, that we're getting closer to being supported in some ways, and we'll be able to do that. So yeah, we want to be able to do some current news, quickie podcasts weekly, if not more often.
Yeah. So we were talking about the Finger Lakes, and one of the things that we'll just quickly review a couple of the details here. We looked at the study that was published in 1989, which was the first seismic reflection profile that was done of the Finger Lakes, where they cruise over the lakes with the boats, and they send down shock waves, and by watching the graphs when they come up, they're able to tell the difference between, say, solid bedrock, sedimentary infill, even able to tell the difference in the texture of the infill. So what to me was quite impressive was that the extent of the bedrock erosion. We found out that was it Cayuga that was 304 meters below sea level. I think that was right. Cayuga. Yeah, 304 meters is just shy of 1,000 feet.
1,000 feet, yeah.
Below sea level. And the other one was 275 meters, also very impressive. And
this is the bedrock bottom of the...
This is the bedrock bottom. Okay. Yes.
Yeah.
Yes. And so they pointed out the radiating pattern in the paper that was published in Geology. And we looked at the radiating pattern and saw that it converged upon eastern Lake Ontario. And right there is the deep basin of the lake, a bedrock basin. And on the bottom, on the floor of that basin, are drumlins with an almost east to west orientation. The paper goes on to say that and ties the Finger Lakes in with the drumlin field. North of the Finger Lakes is an extensive drumlin field and a system of north-south meltwater channels. Now that's really important because the juxtaposition of the meltwater channels, the connection between meltwater channels and drumlins, is very strong evidence that the drumlins are formed by water flow, primarily, rather than glaciers primarily. Although, again, we introduced the term glacio-fluvial because we're looking at a phenomena that really requires both the water flow and the presence of the glaciers, because the cap or the lid of the glaciers forces the water to move under pressure. And it's that pressurized water that we're surmising shapes the subglacial till into the streamlined forms that we call drumlins. But then we saw that they took samples radiocarbon dated these samples, and the samples indicated dates from 12.9 to 14.1 thousand years ago. So we've got a situation where we've got a date, the youngest date is virtually the younger dryas boundary. The older date is a little more than 1,000 years older, 1,200 years older, 14.1. But we pointed out that, if you have a flood, a big flood, which might excavate a landscape that's easily 1,000 or more years old already, then you're going to have organic material that's entrained in that sediment deposit that's going to be older than the flood. That makes sense, doesn't it?
Yeah.
So what you have to do is you have to take a representative sample. Your sample base has to be large enough that, in other words, you might find older dates in there, but if the flood took place at 12.9, you're not going to find any dates younger than 12.9.
Right.
You're not going to find 11,000 years ago or 10,000 years ago in the flood sediments themselves. So what you have to do is, if you have 100 dates and there's a spread and a dozen of them end at 12.9, then that's pretty much going to tell you that was the date of the flood. So what we have is these deep bedrock gorges that have hundreds of feet of sediment infilled in them, and the sediment is massive. We went through the detailed analysis of the sediment and found that at the bottom, the thickest layer was this massive, coarse, bouldery layer, right? And then it gets successively finer, and then the top, the frosting on the sediment layer, is finer stuff that would be characteristic of inwash into the lakes, say during the Holocene, which would have been much finer grained stuff, right? So what does that lead us to conclude? How do we explain that? Well, what that then does is raise the question of, to what extent were those bedrock gorges there prior to the melting event? Or were they not there at all? Are they 100% totally the product of the melting? So we have the Valley Heads moraine at the south end, as it's been called, which turns out to be a fluvial deposition. We have the gorges themselves. We have the tunnel valleys. We have the drumlin fields, right? And we have the radiating lakes. So what we did is we proposed the possibility of Eastern Ontario being possibly an impact site. So that was the gist of it.
If those tunnel valleys were carved that way, where do you think all that bedrock that was plucked up out of them ended up? It ends up downstream somewhere strewn, or is it still down in there as boulders?
Well, a lot of that would be the Valley Heads moraine.
Okay.
That would be a lot of it. And then there would undoubtedly be backwash. But that's a very good question. I'm assuming that a lot of it would have ended up right back in Lake Ontario.
Okay.
So, when you go to the south end of the lakes and you see the gorges down there, like at Watkins Glen and Buttermilk Falls and all of that has been eroded. And we saw examples of giant potholes in those gorges, which shows extremely turbulent flows. Now, here's the thing. We're talking about shale bedrock. So what's going to happen with shale is it's going to, if it's catastrophically eroded, it's going to pretty much disintegrate. It's going to dissolve under those high energy conditions. And probably a lot of that stuff that's in the, sandwiched on top of that bouldery massive layer that's on the bottom is probably what used to be part of the shale bedrock.
Okay. Because I was thinking that you could use the same methodology using thermoluminescence dating on the stone that was cut out of there. And the youngest date should give you the time of the carving of the valleys. But if you can't find any of the boulders that were cut out, plucked out of there by the water, then that would be tough to do.
Right. That would be tough to do. So that's kind of where we left off. And then I don't know if we had this. I'm going to share this. This is showing the floor of the basin in.
So is that, are those features, those drumlin features, they must be covered in Holocene sediments, right? Would that be the assumption?
I think that would be the assumption, yes, because, you've got 10 or 12,000 years of infill into the lakes.
Right.
So yeah, there should be a layer of Holocene sediment draped over
right
the actual bedrock drumlins. Now, question here, let's see, it says glacially scoured rock drumlins.
Right, so they're not deposited, they're actually cut out of the rock.
Now, of course, this is saying glacially scoured. So we've talked about how some of the thinking and the controversies around drumlin formation could have involved, obviously, subglacial pressurized subglacial floods rather than direct scouring by the glaciers. And then I'm just basically saying we have to think in terms of both water and ice working in tandem to create drumlins. But you notice these are skinny and long, a lot of these, and notice that the direction of flow here is from northeast to southwest. So the direction of flow is different than the orientation of the drumlins in the New York drumlin field. Some pictures of drumlins, just so, again, to help people visualize what we're talking about here. Elongated hills. And notice important here, because this is how drumlins are a directional indicator. Blunt end upstream, tapered end downstream. And that seems to be typically characteristic of a drumlin. And notice here again, blunt upstream, tapered downstream.
Yeah, I think it'd be interesting. Sorry to interrupt, but I think it'd be interesting to find out, how thick is the lake deposit layer on top of those drumlins? Are they actually made of rock? And can those lake deposits be dated to give us a time for the drumlin creation there?
Well, I would bet that we could find surveys of the lake bottom. There's probably some dating. I haven't seen them yet, but yeah, that would be a valuable thing to research. No question.
Because we talked about in the previous show, or maybe the previous two, about because they're in a different direction, that we may be looking at two separate flows here.
Right. And the flow across, northeast to southwest across the lake bottom appears to be the younger of the two.
Because it cuts other drumlins that are, okay. Yeah.
Yes. So, and in a previous episode, let's see. So, yeah, let's get this now. We'll do another share screen. And here we go. Okay, so this is on the eastern shore, northeastern shore of Lake Ontario. And they're actually referring to this as Channel Scabland, comprised of a regional suite of sculpted forms across a scoured limestone terrain. Escarpments with re-entrants are prominent. Flutings, all of this. Let's see. Flutings, if you look here, you see these dark curved lines. Those represent flutings. They're called flutings. They're kind of like incipient drumlins. Look, you see some of them down here? Those are what are called flutings. They're not fully developed drumlins, but they would be like, notice down here in the legend, they've got drumlin / fluting. Well, that's because flutings can actually grade into drumlins. So an immature drumlin is oftentimes referred to as a fluting. And then also notice tunnel channel is this line here with the hatch marks on it, and you can see those. If you look up in here, you'll see a number of those. Like here's one right here. So this is a tunnel channel, and it's accepted now that tunnel channels are produced by subglacial flowing water. Goes, you can see there's a lot of these down here. And this inset box shows the region we're looking at. The dark blue here is the Ontario Basin, right? So the Finger Lakes and the Drumlin field would be right down here. Let me move this out of the way okay.
Well, you get a little farther down on that legend, and you do see the crescentic furrows.
Right.
Pointing out some of those arc shapes there, because those are drawn in, right?
Yeah,
so,
those are drawn.
They're
in.
Accentuated. Yeah.
Right. So let's see. The map covers most of the northern land portion of the approximately 100-kilometer flow width. So that's a flow width of 60 miles that extends from a flow feature truncation line near Rochester, New York, to a similar truncation line near Brighton, Ontario. See dashed line on inset map, which you see that dashed line right there. The map compiles 7 landforms, get out of the way there, related to the Kingston Channel Scablands. That's this up here. See, there's the town of Kingston. And look right here. You see this? There's a tunnel valley. Here's another tunnel valley right there. Here's another tunnel valley. And so there are tunnel valleys being carved into the ground beneath the ice sheets. So we have tunnel valleys in association with the Drumlin swarms.
Do we have any examples of those on the surface that we can look at? Like, what does the tunnel valley look like? Aside from did you say the lakes are one?
Yeah, well, right here. This is from Shaw and Gilbert, The Origin of S-Forms, Form Similarity, Process Analogy, and Links to High-Energy Subglacial Meltwater Flows. Right here. Here, see this arrow pointing right here?
Yeah.
There's a tunnel valley.
Okay.
So this is one of the papers that Jerome helped finish posthumously for John.
Yeah, there he is right there, Lessman.
Yep.
Yeah,
Our good buddy Jerome, he was one of the co-authors of this paper. And this is in that paper. This is actually from the ground what the rock drumlins or the S-forms that he's calling it. And the S-forms, again, are part of this continuum of features that would include tunnel valleys and drumlins and flutings. And then the red dashed lines, these will be your crescentic scours, which you can kind of make out over here. You see that, and again, you have to go back and watch the episode with Jerome, because he had the graphics and showed us how the turbulent vorticular water hitting an obstruction creates these crescentic scours. So I will.
That's episode 47.
47. Thank you, Brad. Thank you. Coming further west, over to Michigan, to the Michigan side. Tell you what, before we do that, let me get back to the map here, the national map. All right.
I guess my question on the tunnel valleys is, do they look different, geologically speaking, if you're standing there in one, than a regular valley or a normal valley or a canyon or something? Can you tell the difference? Are there specific features that you can look at and say, okay, this is a tunnel valley?
Yeah, typically they're going to have steeper sides and flatter bottoms.
Okay,
take a look at this bedrock topography here.
Oh yeah.
Wow.
I mean, look, this is an extraordinary landscape. Now, of course, with the topsoil and the vegetation and so on, you don't realize that this is under your feet. But yeah, you can see the scouring here is extraordinary. Look right here, Tunnel Valley, Black River flowing into Tunnel Valley right there. Yeah. But yeah, so this is just east. Yeah, I mean, look at this. This is east of Lake Ontario. And you can see that there is some major erosional stuff going on here. and then zoom out so you can get the perspective of where we're at. Come on out a little further. Let's see, come out a little further so you can see. So there's
That
Lake
whole
Ontario.
landscape there is.
So we've got these extraordinary flow forms over the landscape. Come over here. Look at this. Look at those drumlins. See, we haven't even looked at those drumlins yet. So now that you begin to understand the drumlins, they begin showing up all over the place. Yeah, look at this.
And we're back in New York now, or is this still Ontario?
We are in New York here.
Yeah.
That's New York. Look at this.
Yep.
This is,
Yep.
yeah. So look at this. I'm going to zoom back in. So there's some really chaotic stuff going on here. And then I'm going to come back in where we were looking at the flows into Lake Ontario that left the bedrock drumlins.
But again, that area is probably totally concealed with forest.
Yeah. Yeah. So it's pretty much going to be covered in, sediment, soil, vegetation, forests. But if you stripped all that away, this is what's underlying. So this whole region here, the takeaway from this is this whole region has been subjected to these extraordinary erosional events, hydrological erosional events. Look at this. So here's a tunnel valley right here. You see this? And then it comes down. You can zoom in, and you can see these really long, skinny, drumlinized forms. Again, blunt on the upstream end, tapered on the downstream end. And then we get into the lake proper. And yeah, look at this. This is my computer seems to be a little slow tonight. Here we go. So then we get on to it's too bad this doesn't have the bathymetry of the lake bottom, but we just saw the one map that I showed you showed the rock drumlins on the floor, and those rock drumlins are an extension of what you're seeing right here.
We'll turn off the hydro cache and see if we can see it. Nope.
No.
Nope, it's not there.
Not
Just
there.
flat.
It doesn't show it.
Just thinking if all this was naked like it is in the places in the Southwest we were looking at a couple episodes ago, scientists and just general public would have had a much better understanding of what went on there, because it's right in front of your face, but it's so concealed you miss it. But with these maps and the LiDAR that's coming online, it's going to be so exposed that it's not going to be deniable anymore. Right.
So I mean, what's happening now, and to me this is so extraordinary, that with the technologies we've got and what's evolving here is we're really beginning to see this stuff for the first time ever. This stuff that's been right under our feet for 10,000, 12,000, 13,000 years, and it's just now showing itself. It's revealing itself to us. And right there, it's kind of like a big part of what we're trying to accomplish with this particular podcast that we're doing, amongst other things, is to show that these features of these tremendous events are all around us, everywhere about us, that we have literally created our modern civilization on top of and out of the wreckage of this previous world. And when we look at this, we'll zoom out here. You can see the relationship of the lake here. And what I find particularly intriguing is, again, we saw how the drumlins themselves, the New York drumlin field, is oriented, and we can see it has this radial pattern. As we go to the west, notice that the orientation of the drumlins is shifting. And what the drumlins are doing is they're following the same radial pattern as the lakes, which again is a very clear indication that the genesis of the drumlins and the genesis of the lakes are part of the same process. Look what happens when we go right up here to the rim of the lake. Let's see, we'll come on over here to this part. Let the map come on in. Yeah, let's see. Come on, there we go. Check this out. Now you see the orientation here. Again, see, it goes to that same, it's like, targeting the Bedrock Basin of eastern Ontario.
Yeah, now those might be continuations of the ones that are going across the basin, right?
Well, maybe so.
Yeah.
Let's see here. Yeah, so, it's interesting when you see that. Yeah, look at this. See these?
Yeah.
So there's a radial distribution to the drumlin swarm.
Right. You can see flow patterns in there.
Yeah.
For sure. Yeah.
Yep.
Like some of those over there on the right they start curving down south, where farther to the left, they seem to be curving further north.
Yeah. And of course, there's going to be a lot of divergences and discrepancies because, of course, the terrain, the topography is going to have a big influence on how the flows manifest themselves.
Right.
But yeah, you can see that this whole area is just bears the imprint of these tremendous flows. So coming a little further west, we find, let's zoom on out here. Wanted to come over here to Michigan. Here's Saginaw Bay, which Tony Zamora has proposed as a potential impact site. And it looks pretty characteristic. I mean, look here. Look at this kind of rim. You've got the basin. It certainly looks like it could have been. And we've got some interesting things happening. Like we have here a massive meltwater surge that flowed to the southwest. And if we zoom in right here to this remarkable situation, you see what's going on here? We have a flow convergence here. And look at this. Right here on the floor, the Maple River is flowing in the bottomland here. Here's the upland. You remember the term we learned?
Sub-upland.
Sub-upland, yeah. So here's the sub-upland. So it just, there's, it shows that there's a reason to have the different terms, because now we can talk about the bottomland, the upland, and the sub-upland. Because it's up above the bottomland, right? But it's not all the way up to the top. But look at this. Look at this, what they're calling here the island. So this was literally an island at one point with flow divergence around both sides. And this flow is what created Grand Valley, as it's called, that the Grand River now flows in. And
pretty reminiscent of Steamboat Rock also.
So up there to the northeast, is that Drumlins there?
Right in here?
In the sub-uplands, yeah.
Yeah, looks like it. It's what we would call a drumlinized landscape. They're not fully formed drumlins. But they're definitely in that form. Okay, so I want to stop share here for a second. And then So here's from a paper in 1915, Monographs of the United States Geological Survey by Frank Leverett and Frank B. Taylor. The Grand River Channel, which is what we were just looking at, the head of the Grand River Channel where this flow convergence took place, is the largest and most deeply entrenched glacial river channel in Michigan and is one of the finest in the glaciated area of North America. The deeply trenched part extends from a mile or more above the village of Maple Rapids to 5 or 6 miles southwest of the city of Grand Rapids, a distance of about 75 miles. The floor of this channel is 1 to 1.25 miles wide and shows abundant evidence of having been scoured by a great river. Above Lyons, where the modern Grand River enters, the channel is now occupied only by Maple River, a relatively small, sluggish stream which is lost on the swampy floor throughout its whole course from 2 miles northwest of Bannister. Some few bars of gravel or sand that rise 10 to 12 feet above the swampy floor are distinctly due to the action of a great westward flowing river. So this is way back in 1915, 105 years ago. They were recognizing that, that there was this tremendous water flow here. Now jump forward to 1993. Alan E. Kehew, who a hydrologist who has done some great work on the Midwestern megafloods and spillways and so on, published a paper in Quaternary Research, 1993, entitled Glacial Lake Outburst Erosion of the Grand Valley, Michigan, and Impacts on Glacial Lakes in the Lake Michigan Basin. And he says, geomorphic and sedimentological evidence in the Grand Valley, which drained the retreating Saginaw Lobe of the Laurentide ice sheet and later acted as a spillway between lakes in the Huron and Erie basins and in the Michigan Basin, suggests that at least one drainage event from Glacial Lake Saginaw to Glacial Lake Chicago was a catastrophic outburst that deeply incised the valley. Shoreline features of each lake level converge to separate outlet sills that decrease in elevation from the oldest to youngest lake phases. We'll look at the map in a second. It'll help to clarify that. This evidence, coupled with the presence of boulder lags and other features consistent with outburst origin, suggests that the outlets were deepened by catastrophic outbursts at least twice. Now, a boulder lag is when you have a big deposit of material and it's a lot of boulders in there, but subsequent flows over the top will winnow away the finer substance, leaving the larger boulders exposed. So that's what he's referring to there as a boulder lag. He goes on to say, spillway channels that connect lakes in the Huron, Erie, Saginaw, and Lake Michigan Basin all contain geomorphic evidence of erosion by sudden high discharge events. Although much has recently been written about glacial lake outbursts, the full value of these impressive events in unraveling the Quaternary history of the Laurentide ice sheet has yet to be realized. So, and that was 93. So we're looking at 27 years ago, basically. And at this point, the full value of these impressive events in unraveling the history of the glacial period has yet to be realized. We're not there yet. But in 1993, we didn't have LIDAR, right? We didn't have a lot of the technologies that we now have in the subsequent 27 years that's now allowing us to begin to see these features with an expanded vision. So I'm going to go back to a share screen here so we can kind of get the, all right, there we go. So here we are, we're looking at the whole general Great Lakes region. And part of what we're going to be doing here as we explore further into this region is we're going to begin to question the whole origin and genesis of the Great Lakes themselves and how they might be related to these oversized events. But here's Michigan right here. Notice Grand Rapids. So Grand Rapids sits right in the valley, the Grand Valley. So if we go on a little further here, let's see. So now we've got Grand Rapids right here, and here's the Saginaw Bay right here. So this was where the Saginaw Lobe came down, right in this area. This is Tony Zamora's proposed impact site right there, which, again, we kind of see this sort of same feature, don't we, where we've got a basin with the evidence of massive outburst flood, just like we saw at Lake St. Jean and we saw at Lake Nipigon. And I'm going to scroll back and forth between these so you can kind of see. This is crude, but it was in Key Hughes paper. I've added a little bit of coloring to it to try to make it more discernible. The hatched lines here represents the edge of the glacier margin, right? So above that, all this is ice up here. These outlines here in the light gray are basically showing where the existing Great Lakes are. If we jump back here, see Lake Huron here, the island right there, I guess Manitoulin Island, that's this. Up here is Lake Superior, Lake Michigan, so you can kind of see that. So now you've got the Michigan Lobe coming down here, and the proglacial lake here is Lake Chicago. And then you've got the Saginaw Lobe over here, and you've got what they're calling Lake Whittlesey down here, which is a proglacial lake. And you'll see that there's the Grand Valley is carrying flow from this catastrophic flow from the Saginaw Lobe, carrying it across Michigan, joining into this body of water here that they're calling Lake Chicago, that has another outlet down here on the southwest. And this Chicago outlet is what leads into what is now the Illinois River Valley. And we'll talk a little bit about that because there's some very interesting erosional features along there. Brad and I have visited those. Anybody in this area, if you're interested, go to Starved Rock State Park, and you'll find right there in that park is a lot of the evidence of the catastrophic erosion. So scroll, just toggling back and forth so you can kind of see the relationship. You remember last episode, we also showed the Wisconsin drumlin fields, which are right in here, which splay outward from Lake Winnebagosh right here. Is that Winnebagosh? No, that's Lake, escapes my mind, but it's a continuation of Green Bay right here. So this was a channelized flow that came down here and then spread out into the drumlin field right here. And let's see, I think we can see. Yeah, so it would have, the drumlin field would have been right here under the margin of the ice sheet, and then it would have burst out right in this area. And we saw, I might pull it back up this time, we saw that there was a lot of tunnel valleys that were discharging along the margin of the ice sheet, like the Michigan Lobe right here. You remember we saw the black and white photograph of the big boulders,
right,
spewing out from one of those tunnel valleys.
Oh yeah, the quarry.
Yeah, the quarry.
Indigo.
Yeah. So here is the map showing the outlet region of Glacial Lake Saginaw. So the Saginaw Bay is up here to the right, and you have this flow convergence. All of these little circles here like this represents the boulder lag. See, so there's, if we were to go here on a field trip and travel through this, we would undoubtedly see lots and lots of boulders strewn over the landscape. And you can see how the flow is converging between these systems of moraines here. The moraines, again, were at the maximum glacial extent. So at one point, there would say the glaciers, this was the terminus of the glacier. It receded and built this moraine right here. So we saw this, but this is just to try to give you an idea of what we're looking at here. So here's the flow convergence into the Grand Valley Spillway. There's Maple Rapids that were referenced in the quote I just read. And here you can see all of this flow convergence coming here and channeling down this way, leaving this large streamlined island there. And then it begins cutting the Grand Valley. And again, you see, here's the underfit river situation. Notice the existing, as it says, the small sluggish river of the Maple Valley did not cut the Grand Valley. And here's a closer up view of the island, and you can really get a sense of the disparity in scale between the valley and the modern river that's flowing in it. And hopefully people that have been watching this regularly now are starting to get the impression that many of the North American rivers are flowing in these gigantic channels that they really had little or nothing to do with creating. They're simply occupying the channels that these tremendous glacial meltwater rivers cut in a very short period of time catastrophically. Here shows the town of Grand Rapids. You see the Grand River flowing through here. It arcs to the north and back to the south. And what I've done here is we'll toggle back and forth so you can see the bedrock topography. And of course, the whole town is built right here. And how many of the residents of Grand Valley, Grand Rapids, Michigan, realize that they're living in a topography that was created by a catastrophic flood, which, if it recurred today, would basically eliminate Grand Rapids from the face of the earth. And then down in this area, there's a big sand deposit down right in this area. Let's take some closer look at some of the select areas of Grand Valley. There's the inlet again. And here's near Grand Rapids. And you can see the islands that would have been left in the flow. Again, notice the existing river. Notice the scale of the channel. And here is a Google Earth of Grand Valley, Michigan, where you can see the Grand River flowing in there. And then that gets us to Glacial Lake, Wisconsin, which we find a very similar situation. Notice again the topography here. We have a flow convergence coming north out of Wisconsin. And over here is Lake Winnebago. Thank you. Like the motorhome. Thank you. And we can see part of the Drumlin swarm down here. And we're going to come back and we're going to take a look at this area right here. But I think we're about ready for a break, aren't we?
I think so. And I think you have a co-host who's very upset that you didn't let them in the studio. Yeah.
So I thought I would deal with that situation here. So we'll be right back in a few minutes.
All right.
Perfect.
And welcome back, ladies and gentlemen. Before we get back to the main topic, are we supposed to talk about some other random stuff? That now that you have your quick introduction to the main topic, how's it going, Brad? How you been doing?
I'm okay, man. I was gonna say, I kind of been working on something, and maybe a bunch of people would benefit from it if they kind of thought about this too. I'm working on congratulating myself a little bit more for the stuff I do get done, and not beating myself up for all the stuff that I'm not getting done.
That's
good. Both lists of those are long, but there's so much more that I need to be doing, and I kind of knock myself around for. But be grateful that you're able to get some stuff done. Everybody can't do everything every day. So,
that's
but
right.
we've the rest of us agreed, Brad, that we'll step into the void and spend more time beating you up.
I don't doubt that.
So you don't have to do it yourself.
Yes, you don't have to do that. That's one thing you can take off your list.
That's right.
You can
We're
remove
here for you. We're here for you on that one, Brad.
Well, I'm on the way to Atlanta to pick so I can get some up. I'm way behind.
Okay, you can remove self-flagellation from your list.
Pugilism.
Yep. Yep. I'm sure we all have huge lists of stuff we need to do. And,
Oh God, don't remind me.
Yeah.
Jeez.
Yep. Well, just
Congratulations.
be grateful
for
for
what
those
you are
things you
getting
can get done.
But
That's-
most of it is fun.
That's right.
For me anyway, most of it is fun.
That's what I learned too. In that same vein is instead of stressing about the things that I haven't gotten done yet, when I think about them, I try to realize that, well, when I'm actually doing those things, I'll be having fun. Yeah. And that's usually the case.
Usually, yeah.
Try to focus on that and works out pretty good.
Yeah.
How about you, Mike? You getting stuff done?
When did this turn into a self-help seminar?
Well, since we got back from the break.
Ask me how I was. I'm trying to throw a little,
Okay, positivity, thinking positive. Things are fine here. Thank you very much.
Having a tough time here.
All right.
Things are normal in normal guy land.
See, you
That's
got to
right.
remember, Mike is retired.
Right. So doing
he
things
doesn't
is
have a
not
lot
really-
of obligations. He
Yeah.
just,
have this-
every day is a
handles.
weekend.
I have this one
Mike.
thing I have to do once a week, and it's going to be a real strain. What can I tell you?
Yeah, this is it. I mean,
I have to psych myself up for this every Monday night.
yeah. This is Mike's one obligation every week.
Yeah.
He's got to show up here and try to establish some sense of normalcy.
You don't have to put pants on, and it's a thing.
Oh. Yeah, that's a big part of it. I always have to remind, podcast. Better put my pants on.
Pants.
Required.
Pants is required.
All right. Well,
You
getting
asked
back.
for it.
Yeah, you're right. Getting back to self-help. Don't forget about cbdfromthegods.com.
Thank you.
You want to
Kyle.
help yourself out? Try out some CBD oil, as we've talked about many times on the show. Russ, Brad, and Randall have all tried it, and they've all been seeing good benefits. Randall's wife's been trying the salve. Good benefits there. Painkiller, sleep
Well, my
aid.
old lower back injury has been flaring up the last week, and so Julie's been putting the salve on, and actually I got her to do it about an hour before the podcast tonight, and I'm sitting here because my back had been kind of hurting all day out there working. So she did that, and you know what? I hadn't even thought of it until just now.
Oh no.
That it's apparently not hurting right now.
Well, that's great.
So I don't know. Coincidence, maybe. But
I was believing that story until you said something about working. You lost me there.
I can see that. Yeah.
And I will confirm, the whole effect on sleeping is real.
Yeah.
And it's not like you have to build anything up, because I hadn't taken it for a week probably. And you take some and it's instantly noticeable when you wake up, or that I hadn't woken up 3 times last night or this morning.
That's right.
It really does the job for that. So people have insomnia, trouble sleeping or getting through the morning. Give it a shot. CBDfromthegods.com.
Yeah.
Yep, and,
I will
promo
not
code?
be doing any trips without bringing a supply of that.
Yeah.
Because for me, when I get out in a strange environment, on the road for the first night or two, I don't sleep worth anything. I wake up constantly. I lay there awake. But I noticed that last trip that we did out there in Arizona, thanks to stupid me, I ran off and forgot it, and you came to the rescue, Russ.
Yep. I brought it.
Russ brought it, and I
definitely
was
helped
able
me
to get
sleep
my
too.
dosage and
Yep.
go to sleep. And I think it made a difference the next day. I mean,
Yeah.
I don't do well on sleep deprivation.
Me
No.
either.
No.
Especially not extended sleep deprivation.
Oh man, yeah.
Yeah.
There's studies now showing the importance of getting like at least 7 hours of sleep a night.
Yep.
That's
You know, in
right.
the old days, people used to sleep 9-10 hours. And of course, you know, before electrification and all of that, I mean, the sun went down. Basically, it was dark. You went to sleep. When the sun came up, you got up.
Or you drank a lot of beers around the fire.
Or you do that.
Used to happen.
Right.
Happens all the time. But no, make sure to use the promo code RC Ships Free at cbdfromthegods.com. Helps us out. And thank you very much to everybody who has done that.
Yes.
We really appreciate it. We love all of you. And thanks for watching the show.
And I know that we'll probably get a little flack, but, you know, we may bring in some advertisers because it'll help fund research trips and bringing more cool material to the podcast. But I do want to say this. If we do any advertising, it's only going to be stuff that we vet, that we would actually use or patronize anyway. So
Right.
I think somebody said at some point, you're selling out. Well, to me, selling out would be as if I got up here and was promoting something that I didn't use or didn't believe in just to get the money.
Right.
But if I'm actually using the product and believing in it and thinking that I'm getting benefits from it or whatever, then I don't see that as selling out. And if you do complain about us selling out, the way I'm going to interpret that is that you're ready to step forward and write us a check to subsidize carrying this work to the next level. So if you're not ready to do that, don't accuse us of selling out.
There you go.
All right.
Amen, brother.
Yeah.
So yeah, I mean, technically this is a native ad, right? We're talking about cbdfromthegods.com, promoting the product. It's an advertisement. It's a native ad. We're doing this as a
It's a test run.
It's a test run for the advertising to try to help the show build the metrics so that we can actually expand the advertising operation to get some better revenue. So
yeah. And when we were
really
first
helps us out.
approached about this, I basically said, well, I got to try it first.
Yep.
And wanting to try some CBD. I've tried 3 or 4 brands. Let me try it. If I like it, if it works, we'll start talking about it. So we did that. And I started feeling benefits from it. So I said, yeah, I can do this. I can definitely. And as I've gotten to know, they're good people out there. So I don't mind promoting something that good people are doing.
That's
Yep, right on.
Quite a few people took advantage of the Black Friday special that we offered, so that they added to their other offers that were going on. They got an extra 10% from Randall. So appreciate everybody contributing and trying out the product.
Yep.
Absolutely.
And as far as YouTube goes, you know, every video I've ever watched has thumbs down.
Yeah.
You're always going to make somebody mad. So whatever.
Oh,
We appreciate the people who enjoy the show.
That's right.
although this is something that go ahead, in the interest of full disclosure, we will say that, you know, with Mike's background, if you give us a thumbs down, there is a good chance that you will be tracked down.
That's right.
And that's one of Mike's responsibilities here.
Yeah.
Anybody who
He
gives
will
us a
find you.
negative review, Mike is going to be looking.
Yeah. Mike has people and they may show up.
Yes.
So be careful.
He has people.
Snippers.
Okay. So let's get back to Lake Wisconsin.
The maps.
All right.
Let's
More
get back to
maps.
Lake Wisconsin. So I will do another. Let's see. First, let's get it here. All right. So again, here we see part of Lake Winnebago right there, which is just south of Green Bay. And we see coming off of here, we see the Drumlin swarm. You can see the top end of the Drumlin swarm. Over here, we're showing the how the topography leads to this flow convergence. Right down here, Wisconsin River is now flowing through this outlet of, as it's called, Glacial Lake Wisconsin, flowing around, hooking around this way, flowing to the southeast, hooking around, flowing to the southwest. and Lake Wisconsin is occupying the outlet area. And right up in here is where the so-called Wisconsin Dells are. And you see the Dell Creek, this area right here. Let's see, I think we got some closer in views. Yeah, see the Wisconsin River now flows down. You can see the topography. This was actually a shoreline right here. Oops, at this outlet down here is where the Wisconsin Dells start. We're going to come back to this, but I want to call your attention to some of these little prominences that you see out here, these elongated prominences, some of these things rising up off the flat floor of the so-called glacial lake. Something else I want you to notice here. You see what you got right here?
Yeah, that looks like current ripples.
Current ripples, yeah. The field of giant current ripples right there. So there you see Glacial Lake, Wisconsin. If we go back to, there it is right there. So let's see if I can switch back to maps. But before I do that, you had an outlet, you had a flow. This is where that hairpin turn was, comes down this way. And then you can kind of see the edge of the Drumlin field right over here. So you had water flowing across this way, and you had water flowing from the north, and those flows met, and you can see right here the flat floor, Wisconsin River flowing in there, and once again, the underfit condition. This was one of the spillways that, because there was so much water discharging from the north, it overtopped this ridge right here and cut this channel right through here that is now occupied by Devil's Lake. And some interesting features in Devil's Lake. We can come in a little closer here. So this was carved very quickly by the catastrophic overflow of what's called Lake Wisconsin. And yeah, so here we go. Right now, it's occupied by Devil's Lake State Park. So anybody living up in the Midwest who's visited here, is familiar with this area, familiar with the Dells, you can now begin to appreciate how these features are part of this much greater episode of cataclysmic terminal ice age flooding. Parfrey's Glen, likewise, there's a lot of unique erosion and stuff in there. So let's see here. I think
Randall, while you're on that map, let me point something out to you, because it's one of those things that I told you I'd go back and check, because you were saying, well, one of these places we were overlooking the valley, right? So if you go just beneath or south of Merrimack there, just above where your cursor is, you got a V and a J. Just right. Okay, so that little channel that goes through, that's where Gibraltar Rock is, right there.
Right here, yeah.
That's right where your arrow is. That's where we were on those pictures from Gibraltar Rock. Yeah.
Yeah, thank you for that.
Yep.
Because I've got actually about to show a photograph of you up on Gibraltar Rock looking out over Lake Wisconsin and over this valley, Moon Valley.
There, so yeah.
And really, it's a tremendously beautiful valley, very pastoral, very serene, a lot of farms, but little known to the residents of the area is the catastrophic birth of this valley. And so the next photograph is taken, we see 113 right here. We pulled over and we're looking up, looking to the west, up it's actually a tunnel valley right here, looking up almost straight to the west. It was late in the day. You can see the sun is up here in the west, about to set. So we're looking right into the valley itself. If we went up here and then off to the right, would have been Devil's Lake. And along the flanks of Devil's Lake, we find stuff like this. We find tremendous volumes, masses of broken rock. Now, this broken rock was basically stripped. This is the stuff, this is the rubble left over from the stripping of Devil's Lake Tunnel Valley right here. So there's huge amounts of this, huge masses of this rock that we find all over. And you can see that the distance of transport here in this case is not far because of the sharp edges and it's not rounded off. If it had been transported miles, these rocks would have been rounded off, much rounder boulders than they are. So basically the water rushed through here. It was a short-lived event. It stripped the rocks and then quickly subsided, dumping the rocks before they could be transported long enough distances to become rounded. And here is Brad standing up on Gibraltar Rock, looking out into Moon Valley. And the outlet of Lake Wisconsin was here, and the flow was from right to left across the valley floor. This was a spectacularly beautiful day, a wonderful day to be here looking out over this valley.
And look on the horizon there, though. The 4 mile, 5 mile away, other side of that channel is just barely visible beyond this localized channel. That's more of a distributary we're looking over. But yeah, the wide channel is just those areas way back there, right, is the other side of the huge spillway.
Right. So it came down this way, and then that hairpin turn would have been off the screen to the right, and then it comes back this way. Lake Wisconsin would be just off the screen right up here. In fact, that might be part of it right there. And in the dells themselves, you find all kinds of eroded sandstones like this. This is a pedestal rock. We're learning the terminology here. We've got mesas, we've got buttes, we got pedestals or pinnacle rocks. This is a pedestal because it's got this flared top. So this is a pedestal. A pinnacle would be like this, but no flared top. So it goes pinnacle, butte, mesa, tableland. That's the expanding scale. So what you've got here, now the conventional explanation is that, well, you might have a harder cap rock, so it was slower to erode. An alternate interpretation is that the water coming through here at some point stabilized for a short period of time just beneath this rock shelf. So what it does is it erodes, because for one thing, we know that the dells were created catastrophically by the outflow, the catastrophic outflow of Lake Wisconsin. So it becomes logical to surmise a scenario in which, if you think of the water level initially flowing over the top of the land, but it becomes channelized, and then as the water level is dropping, what it does is it begins to eat away the lower, which certainly could be softer rock. Yes, it certainly could. But that's an alternate explanation for a pedestal rock, is that the water would have undercut simply because it was flowing at this elevation for a while.
So does that equate to Mexican Hat? Is that a pedestal, or
I think so. Yeah. I would conjecture. I don't know for sure, but I would conjecture that Medicine Hat might be an example of a pedestal situation.
Mexican Hat.
What did I just say?
You said medicine. I don't think I said that, but yeah.
No,
we visited into the barely into southeastern Utah there when we were on the way to Valley of the Gods.
Mexican Hat, not Medicine Hat.
Yeah, it's like a big sombrero.
Yeah. And then looking out over the basin of Lake Wisconsin, it's quite flat. In this case, the water was moving from right to left. Even though it's called Lake Wisconsin, here's what's interesting about it. Now, I called your attention to, let's go back. I called your attention to these features, these prominences that you see here. Those are what we see in the distance right here. And when you look at those close-ups, see, we're actually standing on top of one now that rises about 300 feet above the floor, the lake floor, right?
Yeah, that's the one we went up that crazy stairway to get up to the top of that, right?
Yeah.
Yeah.
And looking at it closer up, if you took the trees off of this thing, what would it resemble?
Like a drumlin.
Yeah,
Yeah.
it sure would. And even to the point of you got an upstream and blunter and a longer stream,
More tapered,
a more tapered downstream.
But these would be erosional rather than depositional drumlins.
These would be erosional, yes.
Okay, yeah.
Now, and then when you,
Oh yeah,
Wow.
yeah. Now this is almost 300 feet high right here. This is the one we climbed, Brad.
Right.
Man.
Yeah, you remember that the last 150 feet you carried me up on your shoulders?
Well, I don't remember exactly that way, but I remember it was a tough time.
Yeah.
There was only one set of footprints,
That's right.
and that is when Brad was carrying you, Randall.
And so all throughout
Yeah.
the lake basin, and I'm going to say lake basin with quotes, right? Because a lake would imply a static body of water.
Right.
But there's tons of evidence that this water was not static, it was moving.
What the hell are those?
Well, they're pinnacles, basically.
They're pinnacles?
Yeah.
Wow.
A cluster of pinnacle rocks here, sandstone pinnacle rocks that were left over. Now, here's the thing you got to realize is that what we're doing here is we're standing down here on the floor of the quote unquote lake. And prior to the formation of that lake, the surface of the land was up here. You got it? So this up here was the surface of the land. So all of this intervening material has been removed. Now, that is not a lake per se that did that. This is a massive volume of moving water.
Yeah, it's like a sheet flood.
Like a sheet flood. And in the aftermath, it's left these kinds of erosional forms. And this is the type of etching that you'll see on many, many rock outcrops that are in the pathway of cataclysmic torrential floods. So just look very carefully at the texture of the rock. And then we got to this. We already saw this, but it wouldn't hurt to show it again. Notice the arrows here. And here is the green bay that comes down. That drumlin field is all in this area where it says Green Bay. That is where this splayed out drumlin field is right here. It would have been under the ice sheet, right? Now, Glacial Lake, Wisconsin would have been just south of what they're calling here the Chippewa Lobe, right here. See? So you had copious meltwater apparently flowing out. And look, see here, my point is, we covered this before, but it won't hurt to look at it again. All of these hash marks along here are tunnel channels. So these are discharge points where subglacial meltwater is discharging from under the ice sheet under high pressure. And I counted these. There's approximately 70 of them from down here from south of Madison all the way up along the glacier margin, all the way over to here, right? So this whole area has these tunnel channels. So there was water discharging, huge volumes of water, like right here in this interlobate area, here between the Chippewa lobe and the superior lobe over here. Looked like you had massive discharges of meltwater. That is what would have funneled down here and formed Lake Wisconsin. And then at the flow convergence point, it created the Wisconsin Dells and Devil's Lake that we were just looking at. And so one of these, the Antego Tunnel Valley discharge point, is where the gravel pit is. And in the next picture, you'll see the mouth of the Antego Tunnel Valley, tunnel channel right here, and the boulders that were being carried out. Now, again, what you see here is the roundness of the boulders. as compared to the boulders that were in along Devil's Lake. So this roundness is an indication of transport distance, and the dump truck here serves as a scale. And if you look at the deposits here, you'll see that the deposits are huge masses of flood deposits that were created once the water rushed out from under the ice lobe. It spread out and was just choked with huge volumes of sediment. So you've got
there's like a clear defining line too in the middle of those two. Yeah. Like
right.
It was two different major depositional events.
Right. Yeah. So
quite a few people from Wisconsin wrote in and commented, which we appreciate. And then somebody had actually said, well, the stressors on the first syllable, it's Antigo, not
Antigo. Thank you.
Not Antigo, Antigo.
Antigo.
So, yeah, people are sending us polite corrections.
We appreciate that.
That's
because
right.
I really like to have the correct pronunciations. However, one of the things I've found out though is when you go to, look up some of these terms, and of course you can find pronunciation guides online, even, spoken recordings of the various words, and pronunciations can be all over the place for the
That's
same
right.
word. Okay. But you say Antigo, right? Yes. So what I try to do is look, if the locals call it Antigo or Peshtigo, rather than a lot of people I've heard will pronounce Peshtigo, Peshtigo. But if the people who live there call it Peshtigo. So damn it, I'm going to call it Peshtigo.
There you go.
So if a local tells me it's Antigo, that's fine with me.
You threw me off there. I thought you were adding a third one to Spokane or Spokane. You said spoken.
Yeah, spoken.
Spoken. I was like, wait a second. I never heard that one, but you're talking about the spoken word on the.
Yeah, spoken Washington. Okay, so is it Spokane or Spokane?
Spokane is what I know.
That's kind of what I thought.
Yeah.
That's what I've always referred to it as.
Yeah.
But if you look at it, it looks like it's spelled Spokane.
So I have another question about the previous picture you were showing where it's showing ice flow arrows.
Uh-huh.
When we had Dr. Lessman on, he was showing us similar images, and he was saying that they basically have used the drumlin fields to determine ice flow. And that's what those arrows are indicating.
Well, okay, let me say this. When you go back to the older models of drumlins, it's accelerated. The alternate explanation from Shaw's explanation, which is subglacial hydraulic events, is accelerated glacier flow, accelerated glacier movement. Pretty vague. So far, the papers I've read, it's pretty vague on the exact process, though. I mean, it doesn't have, to me, the clear explanation for all of the factors of drumlin formation like the Shaw theory does. But here's the thing. Ice is going to be a fluid. And in most cases, the water flow of melting ice is going to be the same direction as the flow of the ice itself.
Yeah, that's what I was getting to. So
yeah, right.
That I was just pointing out that Lessman was saying, these arrows are indications of ice flow based on drumlin fields. And I was just thinking that, okay, for the most part, that should be the same, whether it's those drumlins are generated by water or ice. So, but there could be circumstances where it would be different. But or that you could end up with drumlin, with water flow causing drumlins in a place where the ice wasn't flowing like that, I guess is really what I was thinking. But for the most part, they should be the same thing.
Yeah, for the most part.
I mean, the presence of the tunnel valleys is, indicative that the water is going to go a different direction than the lobe itself. The lobe is moving in one direction, but the tunnel valleys are all going in a radial pattern out from the lobe.
Yeah. But when you look at those ice flow arrows, they're even though the lobe is like, say, moving south, you've got these arrows that are always pointing to the edge of the ice. Yeah. And I think that they're judging that flow based on the on the way the Drumlins are radial, but is that really how the ice is moving, or is that just the water? That's really the question I was thinking of.
Yeah, it's a good question.
Yeah. Well, I would say that in most cases, they're going to be in the same direction.
Yeah, it's just interesting because when you have a long lobe like that, but the flow points always to the edge of the ice, that implies that the source of the ice is really the center of the lobe, and then it's having to radiate outwards towards the edges in all cases. And so where's the zone of accumulation if the center of the lobe is always the source? It's just this is a strange thing in terms of where those arrows are coming from.
You mean the lobe is the source of the meltwater? Is that what you're saying?
Well, it would be, but if the ice flow is moving outwards from the center of all the lobes, then the center of the lobe has to be the source of the ice, for that spot anyway. I mean, I'm sure that ice is coming from farther north, but it implies that as it moves down, it's always moving outwards towards the outside of the lobe.
Well, just think of any viscous fluid.
Yeah.
As it's moving, it's naturally going to spread out.
Right.
And what you see is that the Laurentide ice sheet, the accumulation grounds are pretty much over Canada, right? But it's spreading out, and it doesn't spread out with a nice uniform rim. It forms lobes, tongues, if you will, and typically those tongues will often be related to pre-existing topography, which makes sense. If you've got a valley there or a lowland, it's going to be natural for the ice to flow into that, just like water would.
Right.
But if the accumulation continues and the lobe continues to grow, it may just swell beyond the original boundaries, because it's not only going to be flowing away from the zone of accumulation, it's also going to be spreading out, because it's a viscous, you could think of it as a very viscous fluid. Think of something very stiff, like real, almost cold honey or molasses slowly moving and spreading out. And then one of the things we talked about was the importance of differentiating between living ice and dead ice or stagnant ice.
Right.
And we'll soon begin to see the difference. A lot of times I think that some of the tunnel valleys may be the result of water flowing, because once that ice dies, basically what you have to picture is, it's very similar to what we used to see in Minnesota, and you guys probably, Brad would have seen in Pennsylvania, where, the ice, like the snow cover, will break up and become patchy. But in the case of a glacier, as long as it's continuously being fed and that internal flow is consistent, it's a living glacier. But then if whatever happens, the flow from the zone of accumulation is suddenly stopped, and something causes the ice to now just stagnate, it will eventually, what might be a single sheet of ice will end up being separate broken pieces of dead ice, large broken pieces of dead ice on the landscape.
Right. And they won't be moving anymore, which the big massive ice was always constantly moving and sort of keeping whatever was underneath it in a moving state. But once it's stagnant, it can just sit there, and then things can be carved underneath it by water.
Or if you've got pieces of stagnant ice with fractures between them, the water will flow in there.
Yeah.
And selectively then downcut and create tunnel valleys. So a lot to sort out, but it's an interesting study. So we're going to continue, talking about the cataclysmic flood features associated with the melting of the ice, but then we're also going to get into looking at areas that would have not been fed directly by glacial meltwater. We'll probably start with the southeast area, because since we're looking at hopefully doing an expedition into the southeast this coming spring. We'll start talking about some of the stuff that we see right here. And of course, we've seen it all over the Southwest. The erosion, the extreme erosion of the Southwest. And so we're looking at an alternate hypothesis that we're seeing perhaps a succession of cataclysmic flows carving a lot of the southwestern canyon lands and buttes and mesas and things, rather than an imperceptibly slow 1 grain of sand, 1 drop of water at a time. So
Sounds good.
So here we go.
well, it does sound kind of good, doesn't it? So
It does.
and then we got a lot of stuff to get into. Hoping from this that, one of the things that we would establish is that beyond almost any possibility of refutation, that these cataclysmic floods are very real and they have shaped the landscape, shaped the world we inhabit today. And it's not to say that the gradualistic processes aren't operational, because they are. But we have to distinguish between the different modes of landscape formation. And what we can see is that even today, day to day, right, year to year, we do see changes. I walk all the time over in the Peachtree Creek channel and floodplain, which is near to where I live. And in the 25 years or so, 30 years that I've been doing that, I've seen enormous changes. However, most of the change that I've seen has come in a few discrete episodes. Hurricane Ivan came through, probably did as much more work in one event, one day, than all of the combined work of the previous 10 years that I had seen. And we've had a couple of events like that. And so even the smaller events will dramatically accelerate the processes of geomorphic change. What about the larger events? If we're, this is where we talk about a 10-year flood, a 100-year flood. Now, they said that the flooding of Hurricane Ivan, I think they were saying, was a 50 or 100-year flood. I've forgotten. But then that was in 2003, I believe. Four. Well, then in 2009, we had an anomalous, intense rainfall. It was kind of a perfect storm, and the flooding equaled what we had during Hurricane Ivan. And so Hurricane Ivan, I think they were saying, was a 50-year flood. Well, we had 2 50-year floods within 10 years of each other. But both of those two events did more work on that stream channel than all of the other years combined. And both of those events were basically limited to about a day or 2 days each. So one of the takeaway lessons from there is that, there are episodes where concentrated change can take place. So when we go back to, the events at the Younger Dryas and the transition out of the Pleistocene, where would we classify that? We can say, well, this kind of a flow is a 10-year hydraulic event. This magnitude of flow is 100-year. Well, then what happens when we start talking about 1,000-year or a 10,000-year? I think what we're getting at and looking at here is probably so exceptional that we have to go back literally millions of years. And maybe in the millions of years that we go back of the Pleistocene, which is about 2.5 million years, maybe there have been a handful of episodes on this scale. But the most recent one that we are basically, all the drumlins, the tunnel valleys, all this stuff that we're looking at here, it appears that most of it is the result of the whole deglaciation process at the end of the Wisconsin Ice Age. And so we're looking at, a series of events that played out over maybe 3,000 to 4,000, maybe 5,000 years maximum. And within that period of time, there may have been, just like, look, we were talking about the Grand Valley, and he's saying there that, well, it looked like there might have been 2 cataclysmic flood episodes through there, right? We'll see that there's a lot of the evidence suggests that there may have been 2 really big floods that were associated with the melting. When we get to talking about the Ohio River, the evidence there also is consistent with 2 large-scale flood events. When we're looking at the rock drumlins on the floor of Lake Ontario, they appear to be a separate event from the one that created the drumlin fields south of the lake and north of the Finger Lakes. Now, the question is, how much time transpired between the two? I don't know that, and I have not been able to find anybody who's at this point done a study to see what is the exact chronology there.
Yeah.
I mean, they could be very close. And I would suspect that they were close to each other, but it does appear from the truncation of the drumlins. For example, we saw this in the map that the New York drumlin fields, a lot of those drumlins are truncated when they hit Lake Ontario, right? So what that means is the drumlins were there. There was now a flow transverse to the orientation of drumlins that was responsible for the truncation. So how much time transpired? I don't know. There's a lot of questions that still remain unanswered to try to figure this out. But we certainly do, I think at this point, can safely conclude that we're looking at some really extraordinary series of events. We've been focusing on the hydrology of it, but, we've also talked about the mass extinction. It seems to have occurred right there within that window, the collapse and disappearance of the Clovis culture. And we've spent a lot of time looking at the evidence for possibly a cosmic signature, which to me, ultimately, we're looking at events of such extraordinary scale and severity that we have to, I think, be willing to start thinking outside the box and thinking in terms of something cosmic. And we've certainly begun to see the evidence of the fingerprints of a cosmic event. So
you've also got the 2 meltwater pulses.
Yes.
Into the oceans and the sudden huge amounts of sea level rise. So that also would point to those 2 major events.
Yeah. So I think that the model is emerging is that there may be 2, possibly 3 very large scale events, 3 orders of magnitude beyond pretty much anything that we've experienced in the modern world. And within that are some lesser events, but still an order of magnitude or 2 orders of magnitude beyond what we've seen. Because when I say an order of magnitude, I'm talking about, let's say the largest measured flood on the Mississippi River, topped out at just over 1 million cubic feet per second.
Yeah.
And then we're looking at Grand Coulee and we're seeing 300 to 400 million cubic feet per second. Cheney-Palouse Scabland, that sort of thing. When we're looking at the drumlin fields, we're looking at even larger in some cases, assuming that they are hydrologically formed. So those events are orders of magnitude above. And we're going to show this when we get into looking at modern day Yokalaups or outburst floods, and which are catastrophic, certainly regionally and locally catastrophic. But then we're going to look at those in the context of these much larger glacial floods, and we'll see that literally we're looking at floods of magnitudes 1,000 times greater, right? So I think that this is part of what's led to the confusion surrounding the interpretation of the Channel Scablands. Is the idea that there have been multiple floods is certainly true, but I would speculate that there were 2 or 3 episodes that were at least an order of magnitude greater than all the rest of the flooding events. In other words, think about this. Something happens that basically, over a very short period of time, the whole ice complex over North America is living. It's accumulating, it's flowing outwards, it's ablating at its margins, it's a terminus, but it's constantly being fed. The conveyor belt is working, and then suddenly there's vast areas of dead ice over huge swaths of land, right? Well, how did that happen? In other words, kind of, it's almost like we're dead ice. Well, okay, so what killed the ice? See, we're looking for
what killed the accumulation system.
Yes,
what stopped it, right? Yeah.
What stopped it and left, thousands of square miles of dead, stagnant ice just sitting on the landscape. So now think about this: you've got something that supplies the thermal energy necessary to create these huge pulses of meltwater. And then you've got the dead ice. Now, that dead ice is gone, but there were huge volumes of this dead ice. The dead ice had to melt away, right? While that dead ice is melting away, there are going to be very large floods, and those large floods are going to continue until the stagnant ice is basically gone. It's just like a larger scale version of, for those of us who live grew up or live in snowy climates, that when spring comes and let's say you have got an exceptionally warm spring day, you're going to get an exceptionally fast, vigorous melting of the snowpack, right? And the rivers are going to swell, right? And then when the snow is finally gone, the rivers go down, the temporary stream channels stop, I think we're kind of have to think about a process like that, but on a much grander scale. And so you would have had numerous smaller floods, still very cataclysmic, but numerous smaller floods sweeping over, for example, the Scablands, leaving their mark, but juxtaposed on that, or maybe, in fact, the smaller things are juxtaposed on the larger. But, we're going to be getting to the Scablands, and we're going to talk in great detail about the Missoula floods. And, Bradley and I have traveled extensively over the regions from within the quote-unquote Lake Missoula, and outside, followed it almost all the way to the Pacific Ocean, up to Astoria, not to Kalama. Hopefully I'm saying that right. And followed the flood route. And there's a lot of empirical evidence in the field that is not explained by the conventional models of repeated drainings of Lake Missoula. And so we'll be getting into that, and then trying to tie those events back into the much wider scale continental wide events. And then, of course, we have to go from there and start looking globally, because ultimately we are looking at a global phenomena here. And if we use the loss of species as an indication of the loss of habitat, and the loss of habitat as an indication of how much terrain has been destroyed or wiped out in these catastrophes, then what we're left with is that this was probably the most severe traumatic event to afflict this planet in somewhere between 3 and 5 million years. And in fact, if we look at the megafaunal species loss, which is certainly tied in with habitat destruction, we have to go back to the Hemphillian event 5 million years ago to find an equivalent mass extinction event, species loss. If that's an accurate assumption, a realistic assumption, then what that means is that the events that we're looking at here could possibly be the most traumatic events that have happened on planet Earth in 5 million years. And out of the rubble and aftermath of that is what we have created this civilization that we're all now sitting here participating in. So I guess one of the takeaways from this, folks, is don't take anything for granted.
Well, definitely. Let me step back a little bit just to simplify one of your terms there, or clarify, because there'll be a few people that don't get it. But when you're talking about orders of magnitude, you're talking about exponential growth. So it's like an order of magnitude would be 10 times larger.
Yes.
2 orders of magnitude would be 100 times larger. 3 orders of magnitude, 1,000 times larger. So
yes.
Just clarify that a little bit, because some people might not get it.
Thank you, Brad. Yeah, good point. Yeah, if I say 3 orders of magnitude, I'm talking about 1,000 times larger.
Right.
Yeah. So then I can't remember if we were talking this beforehand or at the beginning of the show, but you talked about going to Colomaneros there, and yeah, check on the pronunciation. But I've been out to Astoria and the Long Island on the Washington side there, but that was one of those weird climatic aberrations. Right after we were there was a tornado.
Yeah.
And that's in Western Washington. So some crazy wind gust had gone up west to east down the Columbia River and created a tornado in this little town of Colima, like after we were there.
I think I figured this out because this happened to us too on our recent trip, right? We're driving around with Randall and, suddenly we're going through an ice storm in the desert and then you guys hit a hurricane and you're driving around with the storm god. You got Zeus in the car.
Well, so and so at this point, I would like to take the opportunity to the folks that had to endure that we apologize.
Sorry about that.
We
were just passing through. My bad.
Well, yeah, we were really reluctant to go to Mount St. Helens. It's like, well, what might happen over here?
Well, and see now, look what's happening. We talk about the Drumlin fields on the show, and then 2 days later, a massive fireball.
That's right.
Explodes right over the damn Drumlin fields.
Hello.
Stop it, Zeus.
Well, what that suggests is that somebody is tuning in.
Somebody's paying attention.
Somebody's listening in.
So I was thinking of two things when you were giving your the ending monologue there, and one is that if we had a 1,000,000-year flood within the past 14,000 years, then it seems like statistically we don't have anything to worry about for a while. But if there were two of them right next to each other, then maybe they aren't 1,000,000-year floods, technically speaking.
Right. Well, here's the thing, Russ, is that, what we're looking at there would be clearly a civilization killer.
Yes.
And I mean, we have touched upon, but we haven't delved into all the evidence yet for a population bottleneck, a global population bottleneck.
Yeah.
That seems concurrent with these events that we're talking about. But here's the thing. I mean, an event of much less magnitude than the ones we're talking about here could have a devastating effect on modern civilization.
Right.
So, and I mean, one minor cold episode like the one that happened at 8,200 years ago, we're in some deep trouble.
Yeah.
Because basically we're looking at, a decade of highly compromised agricultural harvests.
It's also just really interesting that if it really is a kind of a 1,000,000-year event, that we're at a point now so close to such an event where we can look at it and get all the detail, because it's not that long ago. So it's not that long ago, we had basically what amounts to either a 5 or a 1,000,000-year event, something that hasn't happened anything like it within the past 5 million years. That has happened within 10,000 years of a civilization that can use LiDAR on the landscape and see it in detail. That's really interesting.
It is very interesting.
Yeah.
And there's all kinds of potential implications of that.
Yeah.
That are worthy of further exploration and consideration. But not the least of which is that the thing I keep coming back to is that, we look at the foundations of agriculture 10,000 years ago.
Yeah.
We look at domestication of animals 10,000 years ago. We look at the dispersion of languages 10,000 years ago. We look at the first urban complexes 8,000 to 9,000 years ago. So what's the explanation there? Well, you got 100,000 to 200,000 years of modern humans roaming around the planet, and nobody figured out agriculture until 10,000 years ago, or nobody built cities. Does the implication that the population was so sparse and so dispersed that nothing comparable to civilization could emerge? But then we get into the question, raised by Graham Hancock, in which I'm saying needs to be seriously considered, which is that there was more going on in the recent geological past that we don't really see the traces of, because what I'm trying to show here is how extensive was this remodeling of the global landscape, right?
Right.
Look at any of these underfit rivers. Imagine even if you just had, communities, villages, they don't have to be big cities, but, what's going to happen in the aftermath of these kinds of events that we're looking at here?
Yeah, they'll be gone. They'll be.
Yeah, I made the point
traces.
about Grand Rapids, Michigan. Well, if those flows came through today, there would be no trace of Grand Rapids, Michigan for anybody to find and look at 10,000 years from now.
Right.
It's just simple the way it is. So don't come to me and categorically state that you think that there could be nothing that happened, during the Pleistocene that we could construe as some kind of a civilization.
Yep.
Yeah.
Yep. That combined with the sea level rise will just pretty much erase most traces. Yeah.
400 foot of sea level rise. So we go back to the end of the ice age, 15 to 20,000 years ago. And you got coastlines that were tens to 50 to 100 miles seaward from where they are now.
Right.
And the rising of sea level, right? So we there's a lot of conversation and discussion and concern now about a 2-foot level of sea rise in sea level over the next 100 years and how catastrophic that's going to be, right? Well, look at the kinds of sea level rise we're talking about here and the kind of meteorological events that would accompany this transition of huge, copious volumes of glacial meltwater back into the ocean basins of the world and the concomitant rapid rise of sea level. We're not just talking about, something like comparable today. We're not talking about that at all. We're talking about something qualitatively very different. So, and we'll get into that. The idea that the turbulence of the seas that are rising because of the influx of all this meltwater and what that meltwater would do to the normal, circulation.
That's right.
Yeah.
All right.
So the hat has gone on the head.
That's right. Kronos has spoken.
And speaking of Kronos, I have one image to share. Speaking of all this Jovian sensibility here.
All right.
Please do.
Let's see it.
Anybody notice a resemblance?
Oh, yeah.
Yeah, is that Brad? Or?
Yeah, well, that's what Brad looks like with hair and a beard. Yeah, when we met, that's what I was.
That's my nose, but I don't know what the.
All we need is earphones on the statue of Zeus.
That's right. Yep.
Hey, wait a second here.
That is old Jupiter right there.
You know what? After I've seen this, I guess I'm going to head to the beauty parlor tomorrow, get my beard curled.
Get everything curled.
Break out the curling iron. Thanks, Mike.
That's what I'm saying. It's the storm god for sure. All right, Brad.
It'd be really cool if I had Zeus's powers.
Yeah.
I'm working on it.
That's what I'm trying to say.
Wasn't that what we were discussing?
That's what I was saying. We're driving around trying to go visit places and storms and hurricanes and ice shit in the desert. Yes,
earthquakes,
right?
Volcanic rumblings.
That's right.
You talk about the Drumlin fields, and a week later or 3 days later there's
Mike 2 days.
Get it right.
2 days later.
Big fireball.
Exploding fireballs. Hey, well, Zeus hurling his thunderbolts,
That's right. It's a thunderbolt. That's what I'm
Exactly.
saying. Yeah,
Exactly.
I called it. All right, Brad, what we got in terms of news or links? People should just check the show notes. Go to randallcarlson.com.
Holy Moses, that's the best place for everything. Randall Carlson, randallcarlson.com.
Yes, at this point, everything Randall Carlson, randallcarlson.com.
That's right.
Keep that in mind.
Yep.
Be a disclosure coming up in the near future. Presumably, we'll see how that plays out.
Yep.
Well, we've talked about it, but yeah, we're gonna do some separate news announcements because I am and Kyle with me are a little bit behind here. So we'll do some separate announcements that will stand on their own as far as moving to HowTube and different things, different products that are going to be for sale, different trips that we're going to be doing, and conferences Randall's going to be involved in. Yeah, we'll make a whole little separate video for those kind of things.
Yep, there's lots of events coming up, so we'll
That's
keep
right.
everybody updated on that as details come out.
And I'll also say now, Rowan, my brother, he's got a whole new batch of T-shirts, including
All right.
white T-shirts that are for sale.
All right.
And
Getting one this week.
yeah, and
All
I've got
one.
a new product I'm going to try. You know, mine and Rowan's younger brother, he's a hunter, and he had hunting dogs that were getting various injuries and sores and stuff. So he's concocted, this is like 20 years on now, he's been developing various salves and things. And he just sent me a batch to try out because he went from animals to humans. And so, yeah, so he's got some really interesting stuff he's come up with. So
you're doing human trials.
I'm doing human trials.
All right.
yes.
All right, I'm all for it.
Me too. So I'm going to, at some point, I may even invite him onto the show for 10 minutes sometime to talk about
Cool.
what he's developing, his alchemy there.
Sure.
All right.
We got a small group of people we could give 15, 20 minutes a piece for and fill up a show with
Yep.
new
Yeah.
modalities like that.
Well, and we're working on
People we know.
some interesting guests. We've got some swap casts coming up that we're planning to do.
Yep.
That's right.
So stay
Checking it
tuned.
That's right.
And,
everything else, check the show notes. If you get a t-shirt, send your picture to cosmographia1618@gmail.com. We've gotten some pictures. Keep sending them in. We're going to we'll put up a place for them on the website. So,
Yep. We're going to have a gallery.
yep. All right, guys. Great show.
All right. Good night, guys.
Good
Good night,
night.
everybody. Thanks for tuning in.
Yep.
Yep.
Thank you all.
Good night.